Iya. Iya, sudah. Ini saya sendiri, Faris.
Iya ini.
Iya. Di aku. Oh, di saya, bentar. Saya di meeting room 1, Pak.
Subset apa itu?
Oke, saya mulai ya, Pak ya.
Ini apa auto right?
Iya, gimana itu?
Bilangnya transkrip.
Tes.
Masuk, Mbak. Dengar loh.
Okay, good morning, gentlemen. Thank you for your attendance in this presentation by internship student. Today there will be Mr. Mev-Ano and Mr. Mev-Ano from Chemical Engineering Institute Technology 10 November, who will present their study under acid plant PT smelting. They've been doing the internship from July 1st, July 1st, 2022 until now, and they studied in the acid plant WWTP area under the supervision of Mr. Rakyat Moko. So these are the topics that will be presented by the students. Anti-scalene optimization in WWTP cleaning section. After the presentation is finished, the audience will be allowed to ask questions to the internship students. And we are expecting questions or maybe constructive suggestions for the students. And without further ado, I would like to welcome the presenters, Mr. Mev-Ano and Mr. Mev-Ano. Please, firstly, give it applause. Give it an applause.
Thank you. So, good morning, ladies and gentlemen. Good morning. This is a day we're looking forward to 1.5 months. The results of anti-scalene optimization in WWTP cleaning section has made us getting a precious moment and experience. The most memorable experience was when we went to WWTP. After a few steps, I felt breathless. Like my room like burning and my eyes like crying. And I thought it was the cases from company next door, but I was wrong. It's from our Gibson reactor. But it didn't stop us. We searched our topic until this day. So let's retell our experience in the first 2 segments. I'm here with Lana Famusa, and he is my partner, Mev-Ano Rajamin. They are from Chemical Engineering in ITS, Institute Technology 10 November. So, in the first week, when I arrived at PT smelting in the morning, I was very fascinated. The atmosphere here and the building here are like in Japan. The sound of this radio, the light of sun, the infinite air, and the wine are like Japan in the morning. And we usually just a taste every morning, like this. It's very heavy. And then this next. Then we move into acid plant. We were supervised by Mr. Marco. He's very healthy. Why? Because he likes culinary. So if you want to get some information about best culinary or best restaurant, you can contact him, right, Mr. Marco?
Yes,
Yes.
Okay.
but for international food only.
Please, okay.
Okay, thank you, Mr. Marco.
Please note that.
And it is our place for investigation letter. And then I want to tell you a story that I have heard of acid plant before. It is a stack, and it releases waste of gases sulfur dioxide. So they said there are some birds through this stack and fall in the ground and die. So after I have this story why they died, because the stack is released sulfur dioxide. The sulfur dioxide is dangerous. So more sulfur dioxide in ppm, more dangerous and more bird in the stack. If you are lucky enough, come here and come around here, and you will find the dead bird in the ground. After I have heard historical acid plant, I took the bird intake in front of the smelting are kept to detect the sulfur dioxide. Is it less or much? Like this bird. Perhaps this bird will be released to the stack to detect the sulfur dioxide. It is less or much. If less, so the lucky bird don't die and it is safe to dispose to the environment. And if this unlucky bird die, so it is not safe to dispose to the environment. And we must increase our rate to keep the limit. But I was wrong. It is for ornamental in the smelting and sulfur dioxide level indicator. Okay, and then next. Yeah, but next, Mev-Ano.
So right, this is the layout of PTS. This is actually an old layout where the highlighted area here is actually the jetty. The jetty is a pier that serves the purpose as a landing stage, which vessel ships can dock. So any kinds of product that will be shipped will be carried over by a conveyor belt throughout this line into the ship to be loaded in. The name of the company itself, this is the smelter plant, where the heart of PTS process lies on. Copper concentrate from Papua is being smelted here up to 1,300 degrees Celsius in the furnace. This process resulting in SO2 being formed and released. Therefore, PTS has built another plant to process this SO2, which will be shown briefly after this. Continuing into the Linde section area, this is the Linde. Linde has its own area within PTS near the front gate. Linde has the duty to fulfill PTS needs in terms of oxygen and electricity supplies, especially for smelter plant. And we head onto refinery plant, where anode copper is then being processed into cathode copper and then transported and sold as an end product. This is the acid VVTP plant, which will then be explained by my partner. Please.
Okay, and then the acid plant. There are three sections in the plant. Gas cleaning section, strong acid, and WWD. Gas cleaning section and strong acid are classified as acid plant, but WWD is separate part. Why? Because acid plant describe the disposal of waste in the form of gas, but WWD describe the disposal of waste in the form of liquid in the environment. So WWD is targeted to make a water that can be discharged into the sea environment. And next. Okay, unfortunately, to make quality water that can be discharged into the environment, there is a price to pay, such as scaling. The scaling attached in this wall and form a thickness about 20 centimeters. As an illustration now, our food, human leg food, the average is about 23 centimeters. So we will detail two steps on this wall. Okay, next. It is the cleaning every constantly once, and then next. Yeah. Formerly, the cleaning was once every 10 months, but recently the cleaning is once every 6 months, and every cleaning spends about 83 million rupiah, and it will be our honor to help smelting to investigate how to slow down the scaling. And this next. And what is scaling is? Scaling is mineral docosides of calcium ion that have precipitated out of the water. Calcium then combined with sulfuric acid in this tank. The addition of sulfuric acid in this tank to decrease the pH because the pH is in this is very high. So where are the calcium come from? Calcium come from here, from this calcium carbonate slurry that to make a gypsum and calcium hydroxide. So increase the pH because the pH in this tank is very low. So they will combine to make a scale, calcium sulfate. And this our research about scaling in this laboratory in smelting. Look at this, the calcium and sulfate are higher than other. So the theory is right. Calcium sulfate is the main scaling problem. Okay, this next. So I want to tell you about the mechanism how the scaling works. Let's say we have initial condition 1000 ppm calcium ions, and when we check in the final, we have 700 ppm calcium ions. And where are the rest? The 300 ppm. The rest are sticking in this wall, and we call it scaling. So, how do we encounter it? Do you have any idea?
Yes, Mev. So these are three of our rough ideas on how to encounter a fast scaling growth in the clarifier. The first possible method is by reducing the calcium injection. We do know that calcium is being injected in the WWTP area, especially in gypsum area for calcium carbonate and sludge area for calcium hydroxide. So if we can find an alternative chemical for this growth, then we may reduce the calcium. And the second possible method is by reducing the sulfuric acid. We do know the contents of scale is calcium and sulfate. So the sulfate comes from the sulfuric acid. Sulfuric acid is being injected in the clarifier area to lower the pH level. So how do we do so? First is we may change the process sequence. For example, if we injected the sulfuric acid in reactor 630, is it possible if we injected after clarifier 650? This may reduce the scale in the used clarifier tank, but it may form in the laundering near the sea. Or we could find an alternative chemical for the sulfate itself by finding another substance, perhaps. As for the third possible method is by using anti-scalant, which is our main topic of research. By finding the optimum dose and types of anti-scalant to reduce the scale in CL650 or clarifier. So let me explain here with another illustration. There is blue dots and red dots. The blue dots indicate the Ca ions, and the red dots indicate anti-scalants. So before we dive into the picture, we must know first what is antiscalant itself and what is the purpose of antiscalant. Antiscalant helps to maintain and balance the calcium ions into its liquid form or phase. Calcium ions, when they are in their solid forms, they are likely to stick into the walls of the tanks. So we could see here with the help of antiscalant, calcium ions, which was supposed to become a solid scale form, are held and bound with the antiscalant into its liquid forms and then flow out of the tank. This would support the earlier theory by my partner, which is the equivalent ppm of inlet and outlet. This concept is actually similar to a soap. Whenever we eat oily food, the oil would stick into our hands. So what do we do? Washing with water won't remove the oil in our hands. So we wash it with soap. Same thing applies to antiscalant. If we don't wash it with antiscalant, then the scale will stick into the walls like oil sticks into the palm of our hands. Thus, in this analysis, we come to our objective is by finding the optimum type and dose of antiscalant by doing lab tests and actual plant tests. These are the three types of antiscalant that PTS has been using throughout the years, which is polygreen by PT Kurita, CX100, and CX20 by PT APC. Although CX20 is still on trial progress. As for the variant of dose for lab research, are 25, 50, 75, 100, and 125 ppm. This then would determine four dose best suited to be tested in the actual plant test later. Moving on, this is our scheme lab test on how our lab research test is done. Antiscalant itself has high viscosity. Therefore, it will be hard to analyze in the lab. So first, we must dilute it with plain water. After diluting it with plain water, we took a sample from the reactor 630, about 4 liters enough. And then we pipette 5 variant of those into the blank sample. So we would end up with 17 total sample consisting 5 DX100, 5 CX20, and 5 polygreen, 1 blank samples, and 1 plain water. We then stored it in the oven with approximate temperature of 50 degrees Celsius overnight. The next day, we head to the lab driven by Pak Marco to do this set of tests, which is filtrating, pipetting, adding nitric acid, and then diluting. This set of tests is done twice for a better result or more accurate. So we will end up with 2 variables for each samples. So if there were 17 bottle samples, then we will end up with 34 bottle of samples. As for the samples, it's then being read by the ICT. Right, so we get the results. We could determine which 4 variant of those we would best suited to be tested in the actual plant test. So we obtain the calcium content for each types and variant of dose of the antiscalant here. So actually the basic idea is the higher calcium content, then the better antiscalant it is. How so? It is because we use the same blank samples. So it would mean that it has the better calcium solubility. So we could see here that CX20 is the highest content, has the highest calcium content. So we might as well say that CX20 is the better among the other two, although it decreases a bit at 75 ppm. As for DX100 and polygreen, they have a similar pattern in between 25 and 50 ppm here. And DX100 has the best performance at 75 ppm. As for polygreen, has the best performance at ppm. The area in circles here are the variant and types of antiscalant that we will be using in the actual plant test. So we would actually be happy to also test the CX20 since we know it has a high performance so far. But due to the insufficient stock at the plant, we ended up testing polygreen and DX100. with a variant of those of 34 ppm and 50 ppm. You might as well ask, why not use 75 ppm since it has a big performance in the earlier graph? The answer is the pump stroke configuration in the WWTP area. It has reached its maximum limit, which is 50 ppm. So at 50 ppm, the pump stroke is already at 100%. So we couldn't go any higher than that. Now these are our actual plan tests. So Matt, maybe you can explain.
So then we did a plant test for 2 weeks. But from 23 July to 4 August. And it is our scheme plant test. This next. Yeah. First, we calculate the average flow rate in that day. So we can get the ppm and the rate of anti-scalan we use, and then we adjust the pump as the targeted ppm. And we take sample every day to outlet. Okay. There are 2 outlets. The one is outlet 630, which is before the addition of anti-scalan, and we can simply say it as inlet 650. And then the last one is outlet 650 after addition of anti-scalan. It's because we want to know the performance of anti-scalan by using this outlet, by testing this outlet. Okay, and then we photo the coupon every 3 days as a visualization, and we did a lab test. Then we get this result. The percent reduction means the percent calcium ions will be scattered, and the closer to 0, the better anti-scalan is. But with this formula, the percent reduction very impossible in the form of negative sign. So this data is some data is invalid, are invalid. And request that there are needed retention time. This retention time take 16 hours. And let's example, when we take a sample in the inlet in the morning, so we will take a sample in the outlet in the night, but we did in the same time because we don't have enough time, and we just know the data, our procedure is wrong when the data was appear. Okay, and next, and it is for 50 ppm. That's 100. Is I know the data and look at this coupon, clean enough for 3 days, and then the next is 50 ppm polyclean. Look at this coupon, very clean than previous flat, and then for 34 ppm polyclean, very worst coupon, please, very worst. And then for the last one, 34 ppm DX100, look at this coupon, better than 54 ppm polyclean, but worse than 50 ppm DX100 polyclean. Because there are some data invalid, so we just conclusion. The conclusion is visual coupon, but the visual coupon is not bigger yet because we don't have enough time for that. So next, talk about the DX100 and polyclean in 54 ppm are very significant. In it. And how about the 50 ppm, Mev-Ano?
Yeah, as for 50 ppm, it is hard to distinguish between them since both performance are similar, not much difference.
Because the polyclean in the previous slide has a optimum doses in 50 ppm, and this 100 has a similarity characteristic as same as polyclean in between 25 ppm to 50 ppm. So how about the JX20?
All right, so as for CX20 test, back in June, Mr. Marco did an experiment by himself by using CX20 with a dosing of 20 ppm. And from we can see here, the result is much better than the other two. As for the lab result is great, and the visual coupon is very clean, despite a lower dosing of injection. So now we have come to our 5 points of conclusion. The first is the rank of antiscalant based on our lab test from the optimum into the least effective ones. First is CX20, followed by DX100, and then lastly polycrene. Second point is GX100 has an optimum dose at 75 ppm and has a low performance at 25 ppm. As for polycrene and CX20 has an optimum dose at 50 ppm and has a low performance at 75 ppm. Third point, there aren't any much difference between DX100 and polycrene at 50 ppm of dosing. As for 34 ppm, DX100 is definitely much better than polycrene, as we can see before in the visual coupon. Coming to the fourth point, less dosing of CX20, resulting a better outcome than polycrene and DX100 with a higher dose. Coming to our last conclusion. So this last conclusion is actually answering our earlier data on the actual plant test, where the calcium content is much higher in the outlet rather than the inlet. This is not supposed to happen, as we all know. But maybe it's because when we conducted plant sampling, it was on a different time frame. So Mev, could you show the scheme again?
Okay.
On the actual plant test? Right. So when we injected the antiscalant at reactor 630, it will need time before it flows out of reactor 25650. Sorry. It will need approximately 16 hours of time of what so-called retention time. So this is the part that we didn't calculate it properly. So what we did is we retrieved both samples at both outlets in the same day at the same time. So maybe that is one of the reasons why. Now onto our recommendation. We have two recommendations. As for the first one is perhaps trying CX20 antiscalant to be applied in the plant. Because as we all know, CX20 has shown us a capable outcome despite lower dosing of injection. And then, so the current PPS dosing right now at WWPP is a mixing portion between polycrene and DX100 with a portion of 50-50 and dosing of 40 to 42 ppm. This dosing is shown in the earlier presentation, which is this is the dosing that needs to be cleaned every 6 months or so. So our recommendation would be to do further research about either the optimum portion mixing of these two antiscalant or the additional injection dose. So I believe that will be the end of our presentation.
Sorry, wait. Can go to the previous slide?
All right.
No. Yeah. The last recommendation, the most important recommendation, and the fourth human say, please get rid of the Kisum oil. I, as a victim, at the first day, very recommend it to make this welding. Whether using copper or using illegal. Yeah, that's for me. Thank you.
All right, then there is another personal recommendation from my partner. I believe this will be the end of our presentation. Thank you. If there are any questions, please feel free to ask us. Thank you.
Thank you for all the presenters for doing an amazing job. Now it's time to question and answer session. For the audience, online or offline, if you have any questions, Please raise your hand first. For the online audience, please raise your hand first and unmute your mic. The presenter will answering later after all the question has been asked. And to avoid misunderstanding for the online audience, after you ask the question, would you please type the question again in the comment section? So is there any question? Okay.
Fine. For boleh.
Yeah.
Okay, for the new chemical, the data of CX20, I believe, back in June, thanks to Mr. Marco, he did research by himself on this new chemical. So the data, we retrieved it from Mr. Marco himself.
So yeah, for sexuality, the source of sexuality is we consult because after annual shutdown 2020, the WTP has a higher flow, so the higher consumption of limestone and calcium hydroxide. So it means the scaling growth is quite faster compared to previous. So previously we have 10 to 12 months for the fire, now reduced to 6 to 8 months. So we consult to our vendor of the Antiscalan, PT APC, which supply the X100 before, and then he suggested the chemical X20. So X20, he said that previously this kind of chemical has tried in smelting long time ago, and the result was quite good, but the price is expensive. So he sent me the free trial of 1.3 tons of one IBC. So we tried at June, we tried the chemical. The result is quite good. And he said that 620 is different formula with the other of Abiscalan. This is the pure polymer, and the other polyethylene and the X100 is mixed between polymer and active chemical. So 620 is pure polymer. So maybe that's the reason why the result is quite good.
Okay, Mr. Firman.
Thank you for your presentation. Very impressed with this presentation. Want to explain here. Very good. Of your friends.
Thank you.
So, I think the important thing is you have been for the basic and the philosophy of our process. And as you might know that we very this is how to learn, how to make observation and plan. Of course, yeah, still we found some need improved. And as the Master Rai explained, question, that, yeah, in your topic is optimization. So, in this case, your optimization is just like political. Because if we talking about the optimization, is we should talk about the holistic overview. So, let's say the cost, and then also difficulties of the supply of the chemicals and the continuity of the chemicals. But I think it's very good for to learn how to. So I think this is my comment.
Okay, thank you, Mr.
So is there any question from online audience maybe?
Pak Yoga mungkin.
Mr. Yoga, would you like to maybe giving a constructive suggestion?
Okay, Mbak. Just comment, not question. I think
Okay.
to the student, Pak Mr. Viano and Mr. Arfa atau siapa panggilnya, Pak?
Mevi.
Alpha. Okay. I think the presentation is good structure, and also the most important is fancy. You made a fancy presentation, so make this interesting for the audience. And I think in general is good, and thank you for the presentation and for the work, the trial. And
Okay.
actually, I want to ask not only to the student, maybe also to Pak Marco. This anti-scalene effect is just temporary. That means only on the clarifier or to the downstream area, because this effluent water will be sent to the sea with long pipes. So this anti-scalene also could impact to the pipes, downstream pipes, or only on the clarifier. Mungkin Pak Marco atau Pak Firman yang bisa jelasin. Itu, thank you, Pak.
Yeah, thank you for your question. So actually, we have been discussed with our student. Yeah, I think this is we can develop to investigate our process. So that's why the students source at the fishbone diagram. So some problem.
Wait. There it is.
So that's why we asked to our student. This important is to make a fishbone chart to detect our difficulties and our status of the process. By this, we can select which one first to solve. So from here, so our student can show up some alternative of the solution for our process. For example, alternative of chemical substitute from the calcium hydroxide or calcium carbonate, and also they said that the chain process sequence. As you might know that right now we don't have the chlorine pond, so the all treated water sent by the piping. I think this become problem at the future. So many times we will decrease the pipe. So we have been discussed with our students. It's very interesting for study for the chain process sequence. Maybe if they interested in this process, maybe they can study more.
Thank you very much.
And maybe
For
also the
for
students-
next study ya Pak. In the final assignment kan.
they have some alternative of the chemical because right now there's like selected chemical agent.
Yes, for reduce the CA in, especially in short section.
So they explain that the scaling is come from the calcium sulfate. There is one of the solution is reduce the calcium amount in our processor, so it can reduce our scale. Itu mungkin Pak Yoga.
Oke Pak. Oke.
Okay, thank you for Mr. Yoga. Nggak ada yang lagi.
Thank you. My comment, maybe not question, just comment. Of all, your presentation is good. Presented many animation that the first impression is quite good. Maybe just for input for you. Next time you want to present it again this method with another person, yeah, please little bit reduce introduction. Introduction is a good opening to make audience interest to your presentation, but please pick up carefully your time and use the introduction brief enough, not to not consume your presentation time too much.
Okay, thank you.
Thank you.
Your step also already background and then explain the cause by before and then step to the laboratory analysis and then I think
Thank you. Tidak apa.
Sudah semua. Nggak ada yang muda. Oh, nggak ada yang muda.
Mungkin terakhir dari kita ya. Terima kasih.
Okay, thank you for all the parties, all the questioners, all the attendees for making time despite their busy schedule, and all of the audience who are already participating by asking questions. As to the presenters, we wish for your great success in the future. And last, Mr. Zakiat Moko, as their supervisor, thank you for your excellent supervision for the internship students. And with this internship, we hope we can gain benefit for both parties. The company will gain a new idea or new point of view from the point of academics, and for the students can gain an insight about the industry. Once again, last, we want to ask the internship student about their experience.
One more thing, Mr. Episan.
Iya.
Commented
Okay.
Yusuf.
Of course, we should lack of the plan so far. So, but I think right now, so we study how to reduce the part of the bonding. Thank you.
Okay, well, Mr. Mev-Ano, there is no.
Maybe last, I would like to thank all the attendants that has taken their time in their busy hours. Mr. Wright, thank you for attending offline, and our online friends here in the teams. Thank you very much. And last but not least, I would like to thank to Mr. Marco, Mr. Hendarta, Mr. Nurudin, Mr. Firman, Mr. Tommy, and all the other people in the exit plan that have taken a huge part in our internship project. They have been an amazing mentor and supervisor for us. We obtained tons of knowledge that we had never knew before, or probably could ever learn in school or university. They have shown us how real life work is, industrial environment, and the most important part is work ethics, etika bekerja. So from the bottom of our heart, we are truly grateful. Terima kasih semuanya. I hope this will not be our last encounter, but in fact, it will be the beginning of our relationship. Thank you very much.
Thank you. Okay, thank you for the online audience. I will end the meetings here. Thank you very much for coming.